Label the following as an expression, equation, or inequality, and then I asked you to translate it. So when I read that, it says 5 times the sum of a number and 23. So to decide what it is, I always
see if there's any indication of an equal sign. Obviously, if it said is equal to, that would make more sense. But what's another word, a small word, that could mean equals? Not necessarily in this problem, but what is a word that a lot of the time is used to tell me that something is equal? Yeah, is, yeah. So that is one of the words that I always look for, is. So is there an is in this problem? There's not. So I'm going to assume that it's an expression. So if you got that it was an expression, that's awesome. So then we need to jump into translating. So if I read those first two words, it says 5 times. Times tells me what? Multiplication. But then it says sum, which sum indicates what? Add. So am I going to write 5 times plus? No, probably not, right? There's one thing that's not very explicit. It's not clear, but you do need to include when you translate. Does anybody know what you should include? Yeah, Trey. Parentheses, yeah, parentheses. Because this is telling me that I'm taking the sum of a number in 23, which I'm going to say is x plus 23, and then I'm multiplying by 5. And the only way to do that addition before I do that multiplication is to use parentheses. So let's see some answers down here. We'll just scroll all the way to the bottom. Oh, that's from my last class. So let's refresh. Oh, that's from yesterday. Oh, why isn't it refreshing? Y'all submitted your answers, yeah? Oh, like, no, I think next just goes to, oh, page. Oh, yeah, that would make sense, right? Page 2. There we go. So it looks like some of you included great parentheses. Good job, Lauren. Robert, good. Beautiful. Okay. So before we get like super into expressions, we need to talk about some vocabulary words that are important, because when I say these words, I need you to know what they mean. So the first word is going to be to the right of this screen. So it says terms at the top. So I want everybody to make sure they can find that. Under your name, Selena. Yes. Yeah, so for what we're doing, you want to use the one under draw, because we're technically not highlighting text, we're highlighting a picture, and like the one under text doesn't work. So make sure you're under the draw tool. Okay. First of all, let's just see if you know. Does anybody know what makes something a term? Minus reading this ugly definition up there. Yeah. Okay, it could include variables. That doesn't necessarily have to include a variable though. Yeah. It could include numbers. Doesn't necessarily have to include numbers. Yes. Which is also a number, right? Yeah. Yeah. It could include an integer. A term is anything that's separated by an addition or subtraction symbol. So if I look at that first expression that says x cubed plus 2x squared minus 5x plus 4, I'm going to underline the individual terms. So the first term that I see is x cubed. That is one term. Then I have an addition sign. Then comes my next term. My next term is 2x squared. That is one term. Notice how those two things are separated by an addition sign. The next thing that comes is a subtraction symbol. And then what's after that subtraction symbol? 5x. 5x would be its own term. And then we have another plus sign. And then what's next? 4. 4 is its own term. So total for this expression, it has 4 terms. X cubed is a term, 2x squared is a term, 5x is a term, and 4 is a term. So I want you to take a second. I want you to do those next 2. I want you to underline the terms and then just right underneath it, tell me how many total terms there are for that expression. So you're doing this one and then the one underneath. Yes. Let me do one thing and let me see if this works. Did you try? You've already tried Addison Xing out and going back in. Okay. Addison, do me a favor, and I would like you to X out totally and then go back in and let me know if that did not work, okay? Yes. It could. Yes, good question. Can a variable be counted as a term? It could. Just like the 4 was just a number by itself, it was still a term. Both of them. So you're doing 5xy minus 4x squared minus y, and then the one at the bottom. Yes. How do you do what? Remember all of what? Because it's on the board. And I read it. I'm really good at reading. Oh, like the one from earlier, because I've done it. This is now my 5th time in the last 2 days doing those same 2 problems. So, you know, kind of like gets ingrained in your brain. Still not work? Yeah, okay. Let's try something else. So just give me one moment. I'm trying to do some problem solving. Okay, so go up to my content library. Oh, look at that. I think that's yours. Yeah. Let's go to draw. There you go. You're welcome. Okay, so for the second one I meant, we have 3 terms, 5xy, 4x squared, and y. Okay, the last one you can just show me with your fingers. How many terms does the last one have? Yep, 4 terms, good. 4ab squared would be a term. 3, although small, is a term. 2b is a term, and a is also a term. So that one total has 4 terms. How do we feel? We feel like we can identify terms. Does anybody have any questions before I move on to the next word? Sweet. Okay. Next word is coefficient, which may be familiar, may not. That's okay. I'm going to apologize in advance. When Ms. Simpkins copied this to your notebook, she cut off the word coefficient. So I wrote it up there if you want to also write it or type it or something so that it's there. This is the one that's underneath where it says parts of an expression. So if you want to write it, type it, I don't care, but it should say coefficients up there. That's my bad. Okay, so I'm sure some of you have heard this word. Does anybody know what part of those expressions would be a coefficient? You can just give me a number, a variable, an exponent, whatever. Yes. Were you reading or you knew that? Be honest. Okay, that's fine. So Asa was able to read where it says the definition, which is fine. It is. It's the number that comes in front of any variable. So if I'm looking at that first one, 2, and I'm talking about the big 2, and I'm going to highlight. This is where I want you to use your highlight tool. We're going to highlight our coefficients. Does anybody see any other coefficients in that first one besides that 2? Go for it. Okay, and I'm going to be more specific. -5. Why is that important? Yes. It would say plus, right? We could technically rewrite this problem as x cubed plus 2x squared plus -5x plus 4. Those are the same thing. So anytime there's a minus sign in front, you want to assume that that coefficient is negative, okay? And that's why I'm even going to highlight that minus sign, so I remember. Do you see any more? Oops, it'd help if you could see it. There is one more, actually. So before you answer, remember the definition. The definition is a number that comes in front of a variable. Nihal, we're looking for a number. Yes. So it does deal with that one, but remember, when we're talking about coefficients, we're talking about just numbers, no variables. You look so excited. What? It is 1. There is an imaginary 1 that comes in front of that x cubed, and it is a coefficient. And it might even be helpful for you to write the 1 in front of those variables that don't have any numbers so that you remember. There's imaginary math all over the place, and this is one of those places. When we have variables that don't have anything, we're just going to assume that that number in front is going to be a 1. So I'm just going to list those coefficients. So our 3 coefficients were 1, 2, and -5. So just like before, I'm going to give you a few moments or minutes to try those next 2. So you're highlighting your coefficients, and then if you want to list them right underneath, you can do that too. Yeah. There would be. Correct. Good job. Lots of highlights. Take about 1 more minute and we'll look at those 2. All right, so the third one actually has 3 coefficients. So 5, or sorry, second one, 5, -4. Again, remember, since it has that minus sign in front of it, it is a -4. And there's another imaginary 1 here, but that coefficient's not just 1. it's -1 because it does have that minus sign in front of it. So for the second one, my three coefficients were 5, -4, and -1. And then the last one had three coefficients, 4, -2, and again, we had that imaginary 1 in front of that A, and that would also be a coefficient. So my three coefficients for that last one were 4, -2, and +1 this time. Cool? All right, last word that we need to talk about is a constant. So, looks like you want to answer. Do you know what a constant is? Can you elaborate a little bit? There we go. That's the key thing there. Not just a number. It's any number that's not, I say married to a variable because they're like together, right? A number that's not touching a variable is considered a constant. So if we go over to our constant and we look at that first one, and we're going to circle those constants, there's only one. What's the only number there that is not associated with a variable? 4, right? 4. So we're going to go ahead and circle that 4. And I want you to be specific, just like we were with coefficients. If this were a minus sign, our constant wouldn't be 4. It would be -4. So make sure you realize that. I'm fine with that. Whatever works for you, as long as you identify it somehow. The highlight tool seems to be a little bit easier to use than the pen tool, probably. What about the second one? Yeah. Where are you getting 1 from? So that would be coefficient, remember, because it's touching, it's married to that y. I heard someone mumble it. No, I know which one you're talking about. That one, right? But since it has a variable, we can't call it a constant. It has to be like a singular number by itself. Yeah, there would be none. I heard someone say 0. That's not wrong, because technically we could just put like +0 and that's not going to change its value. But because that +0 wasn't written, I would prefer you saying none versus 0. And then the last one, what's the only number there that's not married to a words are hard. That's not married to a variable. Okay, which one is it? 3. I agree. Beautiful. 3. Okay, so those are 3 new words: term, coefficient, constant. So I wanted to do a little bit more practice with translating. So if you go right underneath here, you should find where it says 11 more than 4 times the number squared. That's what I want you to be looking at right now. Okay, very first thing we're going to do is we're going to translate this. So without starting, I want you to read it, and I want you to decide, is it going to end up being an expression, an equation, or an inequality? Yeah, Asa, what do you think? I agree, because there's nowhere in there that indicates I'm equaling anything. So let's write it as an expression. So 11 more than, 11 plus. I hope that you notice that in your notebook, there's a new section in there. Go ahead and click on it for me. It should say reference pages on the left. There should be something in there, hopefully, in theory. There's an untitled page, and then there should be something else. That tells you all the words that Miss Simpkins could think of that mean add, subtract, multiply, divide. I think I even put in equals and equality symbols. Is there anything else on there? I think that's it. I'm pretty sure that's all. Oh yeah, like parentheses. That's when we were talking about like the Bell-Work question, the sum of, the difference of, that sort of thing. So anytime we're doing any sort of translating, you have this in your notebook in case you ever want to look at it. So 11 more than 4 times a number squared. So I would say 4, and I'm going to use x as my variable. You can use a different one if you want. Squared. So what I want you to do now is exactly what we were doing before. I want you to underline your terms, highlight your coefficients, circle your constant, okay? And I'll give you a couple of moments to do that. So you're underlining your terms. Yeah, Nihal, you can just do the little caret too if you can't find the squared. On your notebook though, Nihal, if you go to your home screen, you'll see 3 dots that allow you to do like subscript or superscript if you would rather do that. I'm fine with whatever's easier for you. So again, you're underlining terms, highlighting coefficient, and then circling a constant for that one. You have to just click it again, and then you should be good to go. Yeah. Okay. When you do it in like Word, it only does it for one thing and it just disappears. But this one you have to like go in and unclick it. Yeah.
It's like under.
It goes like under.
Like my mouth is like away. Like,
oh. What'd you do?
I don't know.
Do me a favor and click on just like click on something different. I just want to see if it happens. Like on a different page.
Wait.
Like click on one of those. I just want to see if it happens all the time or not. Oh, you're breaking things. Go back to before. Oh, that's okay. So have we tried the X out of it and go back in method? Try that first. See if that works. And then if not, then I'll try and fix it. Sir. Which other one? Like the difference of 7. We're not going to do that one. We're going to do one from the other side of the screen in a second. How do you make the text box bigger? I think if you, let's see. I don't necessarily do text boxes a whole lot. I believe if you put your mouse like on the corner of it and drag, it should get bigger. Is that how y'all make your text boxes bigger? I don't have text. So, Lane, are you talking about the text itself, like a bigger font size?
Yes, that would work. Or
yeah.
Increasing the text box size.
So you can make your font size bigger. Sorry, I didn't mean to interrupt you. Go ahead, sweetie.
I wasn't saying much.
Oh, okay, sorry. If you go home, you can change like the size of your font to bigger to start with, and it'll make it bigger automatically. Maybe that'll help. Try that. Like you have to click home, and then it'll give you like options for like text size. Okay, so we want to underline our terms. So we have 2 terms, 11 and 4x squared are our 2 terms. Our coefficient, there's just one of them, 4. And then our constant, there's only just one of those also, and that would be 11. Woohoo! All right, we're gonna look at one more. And we're gonna look at the one that starts with the ratio of. So find that one on your screen. The ratio of a number and 18. Okay, let's talk about this word ratio. Well, let's talk about division in general. In the history of your math career, most likely, you were taught this division symbol. Okay, it's not wrong, but it's not useful for us right now, okay? The most useful division symbol, in Ms. Simpkins' opinion, is that. What is that? Yeah, a fraction bar. I want you to get used to writing your division problems using a fraction bar. If you're typing, then that little right underneath the question mark, That's what I usually use as my fraction bar when I'm typing, if you want to get a little bit more comfortable using that. Or if you're drawing, you can literally write a fraction bar. What we're about to do will be crystal clear why that fraction bar is important. So let us translate this first. The ratio of a number and 18. So ratio, I think division. So I'm going to use a fraction bar. A number we don't know. So what's your favorite letter? Someone said X first, so there we go. And 18. So in the denominator, we're going to put 18 is equal to. I hope that that's obvious. What should we put next? An equal sign, right? So it's an equation because it literally says in the problem is equal to. Even if it just said is, that would still indicate an equal sign. The difference of, so difference tells me that I'm doing some sort of subtraction problem. The number squared, so we said it was X, so on this side of the equal sign, we want to have X squared and 5. So we're taking X squared and we're subtracting 5 from it, yes. Oh, that's sad. Sure, and then we'll just plug it in during lunch, okay? This is the last thing we're writing before we go to lunch anyway. So I want you to try those 3 things: underlining your term, highlighting your coefficient, circling your constant. Listen to me very carefully. There is only one constant, and there are 2 coefficients. So think about that. There is only one constant. There are 2 coefficients. I'm not going to tell you how many terms there are. You can figure that out. If you want to go ahead and plug in your computer now, you can do that if you want. You can just set it on the counter over there so at least gets a little bit of charge. Put your mask on for me though before you walk all the way over there. Thank you. Almost everybody I'm looking at has one of the coefficients half correct. So just think about that. Almost everybody I've seen has one of the coefficients half correct. Yes. And circle, as long as you know what it says it like right above there, but yes. Underline term, highlight coefficient, circle constant. Okay, let's talk about the obvious things first. So the obvious ones, at least I hope that the obvious ones were the term. X over 18 was a term. X squared was a term. 5 was a term. I saw most people had those 3 correct. The constant, singular constant, was -5. Remember, since it has that minus in front of it, we want to assume that that means that it's -5. And then I saw a lot of people get one of those coefficients completely correct, which is what the imaginary 1 in front of that x squared. And then I saw a lot of people do this. That's what I'm talking about is half correct. Does anybody have any idea why that's only half correct for that second coefficient? It's okay if you don't. I'm just curious if anybody has any idea. So there's actually an imaginary 1 in front of that x, which is included in the coefficient. Let me explain why it's important that we're writing this as fractions. So if I take a number and divide it by 2, that is saying the exact same thing as taking 1/2 of that number. So for example, 4. If we divide 4 by 2, we get an answer of 2. If we take half of 4, we get an answer of 2. These are the exact same thing. So if I were to tell you to identify the coefficient, you would hopefully highlight the entire fraction of 1/2. Same thing as if we have x divided by 4, that is the same thing as 1/4 times x, which again, if we're highlighting a coefficient, that entire fraction would be considered when we do that. So if we're dividing x by 18, that is the same thing as taking 1/18 of x. So our coefficient there would be the entire, if I can get my highlighter to work, there we go, fraction of 1/18. You don't necessarily need to write it as 1/18 times x unless you really want to, as long as it's clear that you are highlighting that entire thing together. That's what I would like to see, okay? Yes. Right, when we're talking about coefficients, numbers, that's it, okay? Just like if it said 2x/3, the coefficient here would be 2/3, right? 2/3 would be considered the coefficient.